Jai Hind everyone. Myself Pooja Sharma. I am Assistant Professor in Computer Science and Engineering Department in Ajay Kumar Garg Engineering College. In today's lecture, we will discuss about the language processing system and phases of compiler in compiler design. Okay, now language processing system. The program that are written in high level language, that is C, C++, Python, Java, are passed into a sequence of devices and operating system component to generate the desired machine code that can be understandable by machine, known as our language processing system. There are four components of language processing system. First is preprocessor, second is assembler, third is compiler, and fourth one is linker and loader. So this is the diagram of language processing system. In first component is preprocessor, second is compiler, third is assembler, and fourth is linker and loader. After that, linker and loader will generate a executable machine code. Now, preprocessor. Our source program can be broken down into modules, each of which is saved in its own file. Our preprocessor is responsible for gathering the source program. All headers files are included in the preprocessor, which also check for a macros presence. It accepts source code and output updated source code. This is the example. Hash include IO streams. Here hash is a preprocessor directory. It copies all libraries function of IO stream file into a program. Now next is compiler. We already know about the compiler. A compiler is a computer software that transforms source code written in one language, that is the source program, into another computer language, that is the target language. The compiler is used for program that translate source code from a higher level programming language to a lower level programming language, that is assembly language or machine code. Okay, third component is assembler. This is a program that that will generate a assembly language code into machine code. Assembly language is a low level set of instruction intended to communicate directly with the computer hardware. So source code will written in assembly language in for assembler. Next is linker. Linker is a computer program that combines and link many object files to create one executable file. All of these files could have been created by different assemblers. A linker primary function is to search and find referred module in a program and establish the memory address where these code will be loaded, resulting is absolute reference in program instruction. Now next is loader. The loader is a operating system component that loads and execute executable file into the main memory. It calculates a program size, instruction and data, and allocate RAM. It starts execution by initializing a specific register. After that, executable code will be generated by linker and loader. Then executable code is a low level machine specific code that the machine can interpret it. After the linker and loader have completed their task, the object code is eventually transformed into executable code. So, preprocessor takes input in high level language and generate pure high level language output that include hash preprocessor directories code also, and compiler will take that output as an input and generate and generate output for assembler, and assembler takes assembly language as our input and generate object code, and that object code will pass to the linker and loader, and after that linker and loader lastly generate the executable code. So this is all about the processing language processing system. Now next is phases of a compiler. We already know about the compiler. A compiler operates in phases. A phases is a logical interrelated operation that takes source program in one representation and produce output in another representation. The phases of compiler are shown in below. There are two phases of compiler: analysis phase and synthesis phase. In analysis phase is also known as front end phase, and synthesis phase is also known as back end phase. Analysis phase is also is machine independent and language dependent, and synthesis phase is machine dependent and language independent. All of these phases of general compiler are conceptually divided in the front end and back end. These division is due to their dependency on the source language or the target machine. This model is called an analysis and synthesis model of a compiler. The front end of a compiler consists of the phases that depends primarily on the source language and are largely independent on the target machine. The back end of the compiler consists of the phases that depend on the target machine, and those portions don't depend on the source language, just the intermediate language. So these are the 6 phases of compiler: lexical, syntax, semantics, intermediate, code optimization and code generation. Lexical, syntax, semantic, intermediate, these are come into the analysis phase, front end phase, and code optimization, code generation will be in back end phase. Now, first phase is lexical analyzer phase. We also call lexical known as scanner. The scanner is the first phase that works as interface between the compiler and the source language program and perform the following function. First, read the character in the source program and group them into a stream of tokens, in which each token specify a logical cohesive sequence of characters such as identifier, keyword, punctuation mark and multi-character operator. So these are the tokens. Okay, next is the character sequence forming a token is called a lexeme of the token. The scanner generate a token ID and also enter the identifier name into the symbol table if it doesn't exist. Also remove the comments and unnecessary space, that is white spaces and all. The format of the token is token name attribute value. So token name comma attribute value. Token represent in this format. So this is the example of tokens. X is an identifier. X is an identifier. Equals to is operator, assignment operator. A is also an identifier. We give the definition to, this is the first identifier and this is second identifier. Plus is an operator, it is a binary addition operator, and B is also an identifier. This is ID comma 3. Next is star is multiplication operator, and 50 is a constant integer. Now the finalized tokenized final tokenized expression is ID1 is equals to ID2 plus ID3 into 50. Suppose this is the example. A is equals to X is equals to A plus B multiply 50. So this example, this statement is represent in this form. Now next is syntax analysis phase. Syntax analysis is the second phase of compiler, which is also called an parser. Parser converts the token that is produced by the lexical analyzer into a tree-like structure called parse tree. A parse tree describes the syntactic structure of the input. Syntax tree is a compressed representation of the parse tree in which the operators appear as interior node and operands of the operators are the children of the node of that operators. So operators will represent an intermediate node and all the operands are on the leaf node. Okay, input of the syntax analysis phase is a token and it will generate output is a syntax tree. Next phase is semantic analysis phase. Semantic analysis is a third phase of compiler. It checks for the semantic consistency. Type information is gathered and stored in symbol table or in syntax tree. Perform type checking by the semantic analysis phase. So after that, this is the output of semantic analysis phase. We give the definition to 5, that is into float. Now next phase is intermediate code generator phase. This phase takes the syntactically and semantically correct structure as input and produce it equivalent intermediate notation of the source program. The intermediate code should have two important properties. It should be easy to produce and easy to translate into the target program. And intermediate code forms 3 address codes, foolish notation, syntax tree, DAG. These are the intermediate code forms. So this is the example of 3 address code. Most commonly used form is the 3 address code. T1 equals to into float 5. We store T1, T2, T3. These are the temporary variable. We store 5 value, 5 constant, 5 value to T1. Then T2 is equals to T3, ID3 multiplied T1. And T3 is equals to ID2 plus T2. And ID1 is equals to T3. After that, we store T3 value to identifier 1. Now the properties of intermediate code, it should be easy to produce, it should be easy to translate into target program. Next phase is code optimization phase. This phase is optional in some compiler but so useful and beneficial in terms of saving development time, efforts and cost. This phase perform the following specific functions: attempts to improve the intermediate code so as to have a faster machine code. Typical functions include loop optimizations, removal of redundant computations, strength reduction, frequency reduction, and so on. Sometimes the data structure used in representing the intermediate form may also be changed. Last phase is code optimization phase. Code generation phase. Code generation is the final phase of compiler. It gets input from code optimization phase and produce the target code or object code as result. Intermediate instructions are translated into a sequence of machine instructions that perform the same task. The code generation involves allocation of registers and memory, generation of code correct reference, generation of correct data types, generation of missing code. So this is the example of code generation. We load ID3 value to register 2 and again then multiply 5 constant 5 value to register 2, that is ID3 multiply ID3 value multiply to constant 5. Again load R1 comma ID2. We load ID2 value to R1. Then add R1 and R2 and result will store in R1. Then store ID1 and R1, ID1 comma R1, R1 value will store in ID1. Now the next phase is compiler design phases. 6 phases of compiler design. Compiler will connect to the symbol table management and error handler. So symbol table management, symbol table is used to store all the information about identifier used in the program. It is a data structure, kind of data structure containing a record for each identifier with fields for the attribute of the identifier. It allows finding the records for each identifier quickly to store or retrieve data from the record. Whenever an identifier is detected in any of the phases, it is stored in the symbol table. This is the example of symbol table. Int A comma B, then float C and semicolon, then char Z, then symbol table and type and address. Okay, this is the token. A and type A is a type of int and address, in which address A will be stored at 100 address 100 A will be stored, and B also an integer and 101002, because integer take 2 bytes, then it B is stored in 1002 address. And C is a float and float takes 2 bytes, then 1004, and C Z char 1008. Okay, this is an example. Again, take one example. Extern double test, double x, double symbol, int count, and double sum equals to 0.0 for int I equals to 1 colon I, and t is equals to count I plus plus sum plus sum equals to sum plus test double I, then return sum. So test is a function, test is a function, and it return double value. Scope extern, x is a type of double, and it is a function parameter. Symbol, sample is also an function, and it return double value. And it scope global, count integer value, sum double I is an integer. Now the last is error handling. Each phase can encounter errors. After detecting an error, a phase must handle the error so that compilation can proceed. In lexical analysis, error occur in separation of tokens. In syntax analysis, error occur during the construction of syntax tree. In semantic analysis, error may occur at the following cases. First is when the compiler detect construct that have right syntactic structure but no meaning. Second is during type conversion. In code optimization, error occur when the result is affected by the optimization. In code generation, it shows error when code is missing. So this is the phases of compiler: lexical, syntax, semantic, intermediate, code, and code optimization. We take an input C is equals to A plus B multiply 5. Lexical analyzers takes this input and generate tokens, and these tokens will pass to the syntax analysis phase, and syntax analysis phase will generate a parse tree for these tokens equals to id comma 1 plus id comma 2, and this is the final parse tree. And this parse tree pass to the semantic analysis phase and generate again annotated parse tree. Then this parse tree semantic analysis output will goes to the intermediate code generator as a input, and intermediate code generator phase will generate a intermediate code, will be in 3 address code form. T1 equals to into float 5, T2 is equals to id3 into T1, T3 equals to id2 plus T2, and id1 equals to T3. And this intermediate code optimization will take this intermediate code as an input and generate optimized code. T1 equals to id3 into 5, and id1 equals to id2 into T1. And this optimization code again pass to the code generator phase, and code generator phase will generate a machine code that is target code. Load R2 comma R3, id3 will be load in R2, and multiply R2 comma 5, multiply constant 5 value to R2, load R1 comma id2 will load into R1, add R1 comma R2, add R comma and R2, and result will store in again R1. Store id comma 1 comma R1 will store in id 1. Phases of compiler. Thank you so much.